Welcome to this introduction on global server load balancing with Edgenexus. What is GSLB, or Global Server Load Balancing? GSLB, Global Server Load Balancing, allows organizations to improve their IT resilience using multiple data centers, on-ground or in cloud. EdgeGSLB uses server health and DNS to direct the traffic across geographical sets based on logic defined by the networking administrator. The great thing about EdgeGSLB is that its resilience is no-touch, meaning that failover, failback, or traffic redirection is seamless should any resources within a data center fail. EdgeGSLB can also drive traffic based on geoproximity, so users can obtain the lowest possible latency when accessing the applications within the data center. Geoproximity means that Melbourne users are sent to an Australian data center, while users in Frankfurt can be sent to their nearest location, London. If the Australian data center fails, its users will automatically be diverted to the London data center until fixes are made. The advantage of using the EdgeGSLB is that it is totally under your control and does not rely on external DNS or other contractual services. Geographical routing. Most organizations use EdgeGSLB in either an active-active or active-passive, high-availability framework. Users can be located across geographies, and their requests are sent to the nearest available data center in order to have the best user experience. End users from across the globe will access their application, with the EdgeGSLB determining where best to route the requests. The routing is decided by the EdgeGSLB based on the geoproximity configuration. The health of each server within the data centers is continually monitored for connectivity and application health, using various monitoring methods. If a problem is detected within any data center, the EdgeGSLB in that location will automatically route the end user to one of the other working server farms. Effective Disaster Recovery, DR. The EdgeGSLB can be deployed to form a highly effective disaster recovery solution. In standard DR scenarios, failure of the primary site would mean that the DNS entries would need to be manually changed to point requests to the secondary DR location and then back again when the failback is initiated. If a data center or a service failure in the primary location occurs, the EdgeGSLB will initiate a failover to the secondary without changing DNS records. The image below shows two data center locations, with an EdgeGSLB in each location, and a continual health check on their respective server farms. Should the EdgeGSLB instances determine that the health of the primary data center or any of its applications poses a problem, the failover to the secondary will be initiated. Zero-touch scalability. Another good use case of the EdgeGSLB is a zero-touch scalability. Let us look at a scenario where a customer has a primary on-premise data center and an additional data center in the cloud, both with several application servers. They have the EdgeGSLB solution installed to provide high availability. They then experience a sudden upsurge in usage and risk their servers being stressed. The EdgeGSLB can monitor the usage in the on-premise primary servers and redirect users to the cloud-located servers when needed. Since cloud data centers can utilize elastic computing, this method proves to be highly cost-effective to use. Installing the EdgeGSLB. Getting and installing the EdgeGSLB is very easy. The GSLB app, like all other Edgenexus apps, can be downloaded via the App Store using an internet browser or directly from the EdgeADC. Downloading from the EdgeADC is achieved via the Apps option in the Library section. If you download it using an internet browser, install it from the Software option in the Configuration page. Once downloaded and deployed, you must configure the app parameters using the instructions in the Administrator Guide. Click the play icon to start the app, and then the Add-on GUI button to launch it. Sign in using the credentials provided, and the GSLB is ready to configure. Installing the EdgeGSLB. Getting and installing the EdgeGSLB is very easy. The GSLB app, like all other Edgenexus apps, can be downloaded via the App Store using an internet browser or directly from the EdgeADC. Downloading from the EdgeADC is achieved via the Apps option in the Library section. If you download it using an internet browser, install it from the Software option in the Configuration page. Once downloaded and deployed, you must configure the app parameters using the instructions in the Administrator Guide. Click the play icon to start the app, and then the Add-on GUI button to launch it. Sign in using the credentials provided, and the GSLB is ready to configure. Our example network. For this presentation, we will use an example network. The network comprises of two data centers, one on the 159 network, with the other on the 160 network. Each DC has an EdgeADC pair with EdgeGSLB installed. Each DC also has a pair of web servers that will serve as the real servers. There is also a global DNS server that is used to hold the NS records and other DNS records. Step 1. Login. To begin, you need to log into the EdgeGSLB platform. Once you have successfully logged in, the first page will be displayed on the right side of the screen. The domain shown on this page is a dummy domain used for illustration purposes only. The first step in using EdgeGSLB is to create a new domain. For the purpose of this demo, we will create a domain with the name gslb.jadc.local. This domain name will be used as an example throughout the demo to showcase the configuration of the EdgeGSLB platform. Step 2. Adding a domain. To create a new domain, you should start by clicking on the New Domain button. Once you click this button, you will be taken to a page where you can add the domain name you want. In the example provided, the domain name used is gslb.jadc.local, leaving all other settings as they are. If you want to use this domain in a clustered environment, follow the GSLB replication section in the admin guide. This section of the guide will provide you with step-by-step instructions on properly setting up and configuring the domain for use in a clustered environment. After adding the domain name, you can click the Submit button. This will save your changes and create a new domain in the system. Once the new domain has been created and saved, the Screen Domains page will automatically update to show the new domain. Step 3. Adding records. The newly added domain is now shown in the Domains table. The next step in the process involves providing DNS records for the new domain. Click on the Manage button, which will take you to a new page where you can add an A-type, NS type, and other DNS records for the domain. Adding these DNS records is crucial for the proper functioning of the new domain in the GSLB system. The A-type record, aka the address record, maps the domain name to its corresponding IP address, while the NS-type record, or name server record, indicates which DNS server should be used for the domain. You can easily add new record types by clicking on the Add Record button by accessing this page. Note the dummy SOA record present in the record set. You will need to edit this record to make it applicable to your domain. You can see how we have edited it for this demo in the next section. Once clicked, you can fill in the necessary details for the record they wish to add and save it using the Save button. This page also allows users to enter any other records they require beyond the NS and A types, making it a flexible tool for managing DNS records. Once these DNS records are added, the new domain should be fully functional in the GSLB system, able to respond to incoming requests and distribute traffic through the ADC. We can now see that several records have been added to the GSLB. The first line states that the Start of Authority (SOA) record has been edited to suit the domain. The SOA record is a mandatory DNS resource record that indicates the primary source of information about the domain, such as the name server that provides authoritative answers to DNS queries. The second and third lines indicate that new name server (NS) records have been added to the DNS configuration. NS records identify the name servers responsible for serving DNS records for the domain. These name servers can be located within the domain or delegated to other domains. The NS records have the same IP addresses as they represent the IP addresses of the GSLB nodes on the ADCs, in the two locations, DC159 and DC160. The last two records are A-type records for the real servers. In our case, these are two web servers named Web1 and Web2. Step 4. Configuring the ADC for GSLB. We now go back to the ADC's Virtual Services page where we can define the virtual services that are needed. We have pre-configured this for the purposes of this video. As you can see, there are 3 virtual services, 2 of them defined with IP address ending 130, and the third defined with IP address 131. The first one shown is the main virtual service for DNS queries. It has been configured to work on port 53 and uses service type, layer 4, TCP/UDP. The second virtual service in this setup is critical to the proper functioning of the GSLB, as it utilizes layer 7 monitors to assess the health of the real servers. These monitors are responsible for checking the status of the servers by examining their applications, protocols, and other attributes. This allows the GSLB to switch users to the alternative DC in case of failures. The real servers for this service are web servers, Web 1, and Web 2, and are defined using fully qualified domain names, or FQDNs. Address entries in the real server section are required, as the Edge ADC looks up the IP addresses relating to the FQDNs configured. It does this by referring to the GSLB configured as the ADC's primary DNS server. The ADC will perform the health check configured in the real server's basic tab to confirm the reachability of the returned server IP and port. Finally, it is important to note that the service name for this virtual service is the domain name defined in the GSLB. This represents what the CNAME entry in the upstream DNS server will be pointing to resolve the IP address for the service the client is trying to access. So in our example, this will be gslb.jadc.local. The third virtual service allows administrative users to access the GSLB user interface. To ensure proper security, it is recommended to keep this virtual service on a separate IP address that is only accessible internally within the network. This way, unauthorized access from external sources can be prevented. When configuring the application, the name given to the GSLB system is used to identify the real server entry. In this example, it is GSLB1. Additionally, port 9393 is designated for this virtual service and the corresponding real server. This port is selected because it is not commonly used by other applications, which reduces the likelihood of conflicts or interference. Step 5. Virtual services. Data within the virtual services section and the enabled status means the GSLB can scrape information from the ADC using the Edgenexus REST API. This also indicates that the GSLB is configured to monitor the health and performance of multiple servers or applications across multiple geographic locations. The enabled status also signifies that the GSLB has been enabled and is active on a specific domain or URL, in our case, gslb.jadc.local. This means that the GSLB is being used to distribute traffic across multiple servers or data centers, in order to improve performance and reduce downtime. We can also see that the IP address associated with the GSLB matches the main ingress virtual service created earlier. This indicates that the GSLB is configured and ready for operations. Step 6. GSLB policies. GSLB policies determine how incoming network traffic is distributed across multiple servers or data centers. These policies are typically configured on a GSLB device or controller, which monitors the health and performance of various servers or applications and routes traffic accordingly. The GSLB policy is set to round robin by default, meaning traffic is distributed evenly. However, the policy can be changed using the edit icon to accommodate different GSLB requirements. Several types of GSLB policies are implemented and selectable for use. Fixed weight. The ADC and GSLB will work in tandem to ensure that the requests are distributed per the weighting provided. Geolocation by city. Traffic is routed to the server closest to the client's city location. Geolocation by continent. Traffic is routed to the server closest to the client's continent. Geolocation by country. Traffic is routed to the server closest to the client's country. Geolocation by proximity. Traffic is routed to the server closest to the client. Round robin. Traffic is distributed evenly across all available servers. Custom locations. The custom locations function in GSLB allows organizations to use GSLB on internal private networks, in addition to public networks. However, determining the location of clients and service IP addresses on internal networks is different from that on public networks. On public networks, the GSLB determines the client's location by cross-referencing their public IP address with a database that contains geolocation data. The GSLB then uses the same database to determine the location of the service IP address and returns the closest IP address, if the load balancing policy is set to a GEO policy. However, on internal networks that use private IP addresses conforming to RFC 1918 for IPv4 addresses, and RFC 4193 for IPv6 addresses, there is no such database available. Therefore, the custom locations function in GSLB allows organizations to manually specify the location of clients and service IP addresses on the internal network. This can be done by creating custom locations based on the subnet or IP address range associated with each location. By using custom locations, GSLB can effectively route traffic on internal networks, ensuring that clients are connected to the closest server or data center and reducing latency and other performance issues. The master-slave concept and DNS replication. You may have instances when you have a pair of GSLB modules running in HA within the same data center, or across multiple data centers running in active-passive or active-active. This scenario, coupled with having a large number of DNS records, creates logistical problems for the administrator. IT staff can end up typing in all the records without an adequate solution for replicating the DNS records, leading to inefficient usage. The EdgeGSLB has a built-in method of replicating the DNS records to slave modules when changes are made to the master, using the master-slave concept to replicate DNS data. Finalizing the setup. The final step is to set up the GSLB in DC2 using the appropriate configuration. Remember to add the NS record for the second GSLB in your master DNS. The two GSLBs will now be working in tandem, protecting your infrastructure. For further information, please refer to the GSLB admin guide located at www.edgenexus.io/documentation. Thank you for watching this video presentation of the Edgenexus GSLB Global Server Load Balancer.